Okay, so references, what a reference is it's what's called a shallow copy of a variable. So you use references when you want to make a sort of alias to a variable. So it's kind of like defining a new variable, but it lives in the same location in memory as a regular variable does. So here we have this integer x. Okay, so every object in C++ has like an address that maps to like an actual like location on your computer's like hard memory storage, right? So we have this integer x, and we'll talk about pointers in a second. But every like object has an address, right? So if we print out like the address of this integer, you can do so by um, the ampersand operator. So when you have the ampersand before any variable name, it'll print out the address, or that just refers to the address, which is um, like a hexadecimal address, and you'll see what that looks like. So if we print this out in x equals 10, so the actual address, the virtual address of x is, let's see. So this is the virtual address of x. It's 0x7ff some junk, right? So 0x just tells you that whatever follows is like a hexadecimal string, okay? In case you don't know, hexadecimal just means like base 16. So the way that the decimal system is base 10 and binary is base 2, this is base 16. So every character can have a value from 0 to f, where 0 through 9 is the same as 0 through 9, and then a through f is 10 through 16, or 10 to 15, okay? So again, this is just a hexadecimal address, and it uses some instruction on your computer to map to an actual location on your like computer's physical memory. Okay. And if we make a reference to x, right? If we say int ampersand ref x equals x, what this does is ref x is a reference to x. Okay. So this is different from saying from like doing int y equals x, because the address of the reference of x here, ref x, is actually the same as the address of x, but the address of y is going to be different. So we'll see the address of those again. So we'll say um, ampersand ref underscore x, and then ampersand y. So if we run this, you can see that ref x and x actually have the same address. Okay, and what that means is that they are basically like inextricably tied now. So if you try to modify one, the value of the other will also be modified. So we'll do examples here where you'll see that if you modify x, ref x will also be modified. And if you modify ref x, then x will also be modified. And that's because they're just the same variable, right? We didn't make a new variable when we did ref x. We just made like a variable name to refer to the exact same thing. But when you do int y equals x here, it actually makes like a copy that's distinct in memory, which you can see here, right? So this y is at a separate position, and if you change x or y independently of one another, then the other one will not change. So so here let's set x equal to 20 using ref. So if we do ref underscore x equals 20, and then we print out both, compile this. So you can see here that even though we didn't like change x explicitly, since ref x refers to the same variable as x, right? If we change ref x to 20, then x is ref x technically, right? So x is also going to be changed to 20 because again, they're the same exact address in memory. And then the same thing happens the other way around. So if we set x to 30 and then print those out again, then ref x will also be 30. And we can do this practice again. Yeah, so you can see here that we just changed x to 30 here, but x and ref x are both 30. And then just for proof of concept, we can print out y as well. And you can see that y is not going to change because y is like a separate variable, while ref x is just an alias to x. So references are useful when in like when you're setting up classes or any program, you need a variable that can like refer to other variables. It's useful in functions. The main purpose of references is when we make functions and we want to pass in things that we're going to edit directly, which we'll see here. But yeah, that's the main takeaway, which we'll go over in a second. So we're going to make a function called modify value, and it's going to take in an integer reference, okay, which is called passing by reference. And if you don't take in a reference, then the value passed in is actually not going to be able to be modified by the function. So here we'll say int modify value, and it takes in an integer a, and then we'll just say a times equals 2. And we'll make this void because we're not expected to like modify this parameter to do something to the parameter so that when we print it out again, it'll have changed. Okay. So we can comment these out. So as far as we're concerned, x is 30 here. Okay. So we're gonna call modify value, and we're gonna see what happens when we try to just pass x in normally. So if we do modify value x and then print out x, what we're gonna see is that it's actually 30. So even though we passed in this x variable into modify value, we multiplied it by 2, we just got 30 back. And the reason is because the way that functions work in C++ is that if you don't pass in a variable by reference like this, it's actually going to make a copy of the variable a. So it's going to enter what's called a stack frame, which you don't need to know about in this course really. But it's going to enter this function, and this int a that it creates to work inside this function is going to be a copy, the same way that when we do int y equals x, it makes a copy. And that's what's called a deep copy, okay? So it's going to be a copy of the variable that's stored at a different position in memory. So this int a that's operating on actually has a different address than x here. We can prove that by doing, the address of a here and the address of x here. So we can do and then I'll actually print out the address of x afterwards so that you know that this function call isn't doing any funny business to, the address itself. Yeah, so look at this. So we printed out the address of a here, which was the x that we passed in initially, right? And it's this address, but the address of x itself inside this scope is actually different. So this shows us that if we want to modify this x value, it's not going to work because we're modifying something else entirely. So the way to resolve this is by passing in a reference, because when you pass in a reference, right, you're passing in the position in memory. You're passing in the variable that is going to be exactly the same variable inside main. Okay, so this is just by convention in C++. Most things you want to pass them by reference because otherwise, right, you're going to be making unnecessary copies of variables and you're not going to be able to edit them like you want to. So if we do an ampersand here, then we'll see how it's different. Yeah, so now you can see that these two are in fact the exact same address and that our x actually got multiplied by 2 this time. Okay, so this sort of concept applies to anything, whether you're working with integers that you want to modify or like, let's say strings or vectors, or even like classes you make, right? If you make some class foo and you want to modify that class, you have to make sure you pass it in by reference because whatever edits you make to the class here will not be reflected outside main, outside of the function call. So make sure you guys remember that. Basically everywhere you show up, like this is the most important like takeaway from references. So just make sure that you understand the importance of passing by reference. It's also used in lab proof, so we'll look at that as well. Now let's look at pointers. So pointers are kind of like references. They both like kind of do the same thing, but the syntax is different, obviously, right? And pointers are not like the same data type as the thing that you're referencing, like references are, but they're actually like the address itself, the address itself of the variable. So we'll see how that looks. So if you have a number here, remember how I said that you can print out the address of that number by doing the ampersand operator and then num. So this way, so you can actually store this address inside like a pointer variable, right? You can store inside a variable which is called a pointer. So the way to do that is you would declare a pointer by doing int and then star. So this star means that it's an integer pointer, and then we'll call it num pointer. And then we'll set that to the address of num. So what that'll do is this num pointer, when we print it out, it's just going to be the address of num. Okay. So let's print these two out. Let me get rid of this. Yep, so when you run this, we're just going to say that num is 35/3, and this is the address of the variable num. Okay. And then if we print the address of the pointer's pointing to, it's just whatever this is. We can also print the address of the pointer. So it's kind of weird to think about, but pointers themselves are also objects. So if you have like a pointer that tells you where a certain thing is located, that pointer also has its own address. So there'll be a pointer to, not a pointer to that pointer, but that pointer has an address telling you where that pointer itself is located because it needs to exist in memory, right? So you can also do something like cout ampersand num pointer. And this is really not that complicated. As long as you think of like num pointer as being like a distinct object from num, apart from just being an address. Um, it's an address, but in order to point to something, it has to be like held in memory, right? So any object in memory has its own address, which is why you can dereference it here. And then obviously, if you want to dereference num pointer, right, you can do the star operator. And the star operator tells you like what this pointer is pointing to. Yeah, so it's just 35/3 because this address points to this number. And then you can also use pointers to modify like original variables as you do references. And pointers are actually more useful when it comes to classes and stuff because references cannot be declared, which I didn't really go over. So if you try to do something like in ampersand ref here, it's going to throw a compiler error. Like you're literally not allowed to do this. It has to be like set to something. It has to be set to reference something. Whereas with the pointer, you can definitely just do, uh, you know, in pointer, in star pointer. And while this doesn't point to anything yet, and you can't dereference it, you can still do this syntactically. Like it's still valid. So it gives us a little more leeway sometimes. But functionally, like pointers or references can be used to do the same thing. Um, and then there's also the dereference operators. So if you want to dereference pointer, right, you can use star num pointer like this, like how we did here. But let's say you have like a pointer of an object. Okay, so let's say we have like a class here. It has like a single integer. So you can also make pointers that point to class objects, right? Pointers can point to anything, right? Because every object has like an address. So you could do something like, you could do foo pointer equals, we'll just call like a constructor, and we'll say that the constructor, we'll make everything public. We'll just say the constructor sets num to 0, or let's say 100. So if you do foo pointer equals foo, then if you wanted to like, let's say edit this variable or like call any function even, right? You could either do star pointer dot, and then you could do dot num, for example. So we'll do this. Uh, oh, it's the address of this. So I'll do foo So I'll do this. So foo f is just a defaultly constructed foo object, and then this foo pointer PTR points to the address of that. So if we print out the dereferenced pointer num, then we get 100. But you can also skip the dereferencing and the dot operator, and you can do it all in one step by using the arrow notation. So you can do PTR arrow. And what that does is it directly dereferences PTR down to F, and it calls F dot down. So it's the same thing as what I did earlier. And that's why when you do like initializations for constructor, like here, if you do this arrow num, the reason why you do the arrow operator, not the dot, is because what this is, this keyword, it's actually a pointer to like the class instance that you're working in. So this is just going to be the address of like the class instance. So here, if I do foo f, PTR here is the same as this keyword. Like they'll both reference the same thing because they're both addresses to f. Okay, so that's why I use arrow notation. And if you run this, you'll see that this is also valid. Okay, so that's kind of like a brief overview of like pointer and reference syntax, and I'll explain how it works in Lab 3. But does that make sense? Do you guys have any questions? Okay, so um, let me yeah, let me talk about Lab 3 actually. So yeah, I'll keep this in recording. So in Lab 3, what you're gonna do is, I hope most of you have started it, but you have to make this contact book, okay, which acts as like a phone book, or yeah, a phone book, and it stores like individual contacts. So your contacts are like one class, and the contact book is like a sort of like container for all the contact classes, okay, but it's gonna have all these special functions that allow it to like act as just like more than just a container, okay. So there's some background about array syntax. It's pretty simple, and then pointers and reference to and over. So yeah, for the structure, you have like a class pointer here, okay? And these are just you have a name and a number for each class, for each contact instance. And then for a contact book, let's look at the member variables. So this static const int max size, what that does is it just makes max size like a constant that you can't change. So it's useful. It's just useful if you want to have like a variable to refer to as like a constant. For example, like if you're making pi, and you want to set pi equal to like the value of pi at the beginning of your program, that would be like where you would use like static constant. But it used to have like an address book of 100 contacts here, which is an array, and it's an array of contact pointers. The reason why they're pointers and not just contacts is because in a lot of programs, like even for like data structures, you'll have like arrays or vectors of pointers to objects, to the actual objects, because if you just store the objects, then if you store pointers, then you don't have to worry about like making copies of those containers, okay? So let's say we have this like contact array of just contact objects, okay? And we make a copy of it somewhere. If you make a copy of that, then the contact objects inside that array might be different contacts, okay? So if you have a contact array of pointers, or it might not even work. So just know that you should use pointers in this case because pointers are always easy to like dereference down to the object. For now, you can like mostly take for granted that you're using pointers. And like as you like once you get to linked list and stuff, it'll make more sense why we choose to work with pointers primarily. But yeah, don't be too worried about this. Just know that you're storing all the addresses of where the contacts are. And you have the current size. So for some of the methods, you have a parameter constructor, and then these getter functions. And for displaying the contact info, you just display, the name and the number. For contact book, it's a little more tricky. So you have the constructor, and then you have a find function. So the find function takes in a string, and you have to return the found contact as a pointer. Okay, so all you would do is if you have an array of contacts, right, in your contact book, you just iterate through that, and then you once you find the contact matching the string, you return like that contact pointer. Okay. And the way to work with these like contact pointers, like through the pointers, is again use a dereference operator, right? So if you want to like if you're like going through a bunch of pointers and you want to check like all of the underlying class objects, like names, for example, whatever the name of your contact pointer is, like if it's in a for loop, it'll be like contacts bracket I, right? So that thing will be a pointer, and you can always use the arrow notation to get to the name, and then you just call the get name function to get the name of that. So for example, if you're in a for loop, right, contacts I, then arrow. Okay, so remember the arrow lets you access the contact that is held at this contact pointer because this contact's I is of type contact pointer, so it's an address to contact. So this just gets you to what's at the address, and then you can just do get name, for example, and that's the same as doing again star contacts I dot get name. So you can use whichever one is more comfortable for you. If this just makes sense, you can use the dot notation after the star operator, but this is just like a shortcut, so to speak. And then add just adds a contact object to the end of the contact book. Okay, so your contact book is going to be an array of contact pointers, and as the contact book fills up, each successive like position in the array is going to have a new contact pointer. So this stuff in bold is kind of useful. So they'll never try to add a contact that already exists. So you don't have to worry about that edge case. The only thing is you have to make sure the order of the contacts in the array is preserved, but that shouldn't be a problem as long as you find like the first empty spot in the array, right? So again, in contact book, you have this like num current size, and you can use the current size variable to keep track of like where your first empty slot in the array is, right? So that's the add function. And by the way, you have these operators on here. So when you do plus equals contact, you're just going to be calling the add function here. That's what you can do because it does the same exact thing as add, but just in like an operator supported way. And then add contacts takes in a vector of contact pointers, and then it just basically adds each of those one by one. Okay, so you can just use the add function again. For this plus equals contact book, you're going to be adding like two contact books together instead of like just single contacts at a time. So if you add a whole contact book, then again, you have like your original array and then your second array from the contact book that you're adding. So you can just like go through all the contacts in the second array and then add them one by one using again that add function. So make sure you use your functions over and over again because most of these you can like use pretty repetitively. Remove is probably going to be the hardest part, to be honest, of this because you have to like shift all of the contacts in front of the remove contact in place. Okay. And something that isn't explicitly stated in the instructions that you have to do is that for the minus equals operator, right? For contact and contact book, it also asks you to remove contacts that match in the passing contact, just like the remove function. But for those, you also have to like shift everything in front back by one. Okay. So even though that's not explicitly stated, you can again just use the remove functions. Okay. You can use remove for minus equals contact and for contact book. Okay. So that's remove. And then for display, you'll just iterate through all your contacts in your contact book. And since they're pointers, again, you just dereference them using either the star operator or the arrow, and then just call the display function, like how we showed. Alphabetize is kind of hard also. It requires sorting the array in order. You can do this in like a vector or something. You can have like a separate data structure to store like the correct order, and that might help you. But for that one, it's mostly logical, like a logical problem, not so much like syntax with the pointers and stuff. And then the operators all like just build off of like the add and the remove functions. For equals, equals, and minus, not equals, you can make one and then just use that for the other one. But you just check to see if all the objects are the same in each one. So the pointers, they don't have to be the same pointers because remember, again, pointers have their own address, but the pointers in each one have to be pointing to the same object. So that's equals equals, and then not equals is just inverse of that. Okay, so Do you guys have any questions about any of the functions? If I like ran through any of them like too fast, you want me to like explain any? Yeah. So I think max size of 100 is like given to you by the instructions. So that's just telling you that like because when you work with arrays in C++, they have to have like you have to give them a size, right? You can't make it dynamic, so you have to be like, hey, this array is exactly 100 elements long. So we're just telling you that like the array is going to be 100 elements long. Does that make sense? Just default 100. Yeah. Yeah. Yeah, sure. Oh, oh yeah. I guess we haven't done operator overloading. So if you guys have done lab 2, wait. Okay, I'm not sure, but yeah, operator overloading. Okay, so I'll show you the syntax if you want for like the functions and stuff. That might help. So let's say your contact the class, and I'm not gonna write it out fully. I'm just gonna give it like I'll include the variables, and then I'll just write out like one of the operators, not the functions, but like the syntax for like writing the function. So if you want to do, let's say, I don't know, plus equals. So we'll say operator plus equals, and then like a contact book. So this is what the declaration looks like. Okay. So it's operator. The operator is a keyword in C++. So that's why it's like a valid name. But you need a return type too. So if it's plus equals, then I think you return a contact book reference. We can make sure. We can see if it tells us. Okay, so since plus equals contact is like the add function, and plus equals contact book is like add contacts, they both say that they return nothing. And I guess the reason why it returns nothing is because the plus equals operator like acts on the class instance. Okay, so we don't need to return anything because we're just modifying like the class object itself. Okay, so it'll be void. So it's void, and then when you're defining it, right? If you're gonna define it like out of line, then you would just do void and then contact book colon operator plus equals. So I know it looks kind of weird, right? And then this is like a name. So we'll say C. Also notice how like this is passing by reference here. Um, it's a good habit to do this, even though here you wouldn't actually be modifying C, so we don't need to pass it by reference. If you pass it by reference, again, you're saving memory because these objects that you make can take up a lot of memory on their own. So we just could have it as a reference. But if you're defining it out of line, then you just have contact book colon, which is the scope resolution operator, and then the operator keyword, and then plus equals. And what this allows you to do is that once you define this, you can do something like contact book, and then contact book, new book, and then you could do book plus equals new book. Okay. And normally like this kind of thing isn't defined at all for classes that you make because like what does it mean to add two contact books if you don't tell like the compiler what that means? Um, Also like book minus new book doesn't mean anything either, right? Because they're not like integers or strings or like there's like defined operations. You have to define them. So that's what operator overloading is for. And that's like the kind of syntax that you do with. So you just do colon operator and then followed by the actual operator that you're going to overload or define. Does that answer your question? Yes. Okay. Any other questions about the lab? Yeah. Yeah, so it's void because like logically, right? What you're doing is you're taking in this contact book and you're adding it to the object that this is operating on. So for example, like if we're doing book plus equals new book, we're just adding new book to book. Let me that's a good question though. Let me make sure. It might not be void, but let me make sure real quick. So give me 1 second. Okay, that's a good question. So actually, let me briefly go over like the return types of the different operators and like when you make them void and when you wouldn't make them void. Okay. So in this case, right, let's say we do um plus equals. Okay. So if we were to write it like a very rough like pseudocode for this, right, it would look like uh so if contact book has this array contacts, then it would look like contacts plus equals c dot contacts. Now, obviously, this isn't what you do, right? You can't just add arrays like this, but you'd replace this by like actually adding the contacts from C one by one into this contacts array. The reason it's void is because you're just modifying this contacts array. So when you come here, right, book plus equals new book is going to modify books like contacts array to include the new contacts. So you don't need to return anything in that case. But if you're doing, the plus operator, so oh, I'm sorry. Yeah, thank you. Sorry about that. Okay. Yeah. So if we have this plus operator, and I'll write it in the class as well. So the return type of this is not going to be void. It's actually going to be a new contact book. The reason why is you want to think about like how the operators are actually used inside the main function, like whenever you define it, right? So what the plus operator looks like is what it does is you just add two contact book together and you return the resulting contact book. So this one actually tells you that like you're actually returning a contact book. Okay. So you would do let's see, you could do like you just do this and then return. So yeah, there's a couple ways you could do this, right? You could return, you could operate on like this contact book. Let me just do an example here in main, and then I'll show you like how everything sort of interplays with the function. So let's say we want to do contact book. Um, book, I don't know. I'm gonna do different names. Let's say book one, book two, let's say book three. So let's say contact book three equals book one plus book two. So in this case, right, the plus operator here has to be assigned, the result of adding these two things have to be assigned to book three. So in this case, it actually does need to return something because we're taking like the sum of the two books and we're using that as a contact book. Okay. Whereas when if you were to do book three plus equals book one, this whole thing doesn't have to return anything because we're just modifying book three. So when you see them in the context of like how they're used in main, it makes a lot more sense, right? And if you were to go here, right, in this case, book one is going to be what this pointer is pointing to. So book one is going to be, this is going to be equivalent to doing like book three equals book one, and then like dot operator plus book two. Okay, just to visualize it for you. So this is sort of so this, so this is sort of like the left-hand side, and then C is like the right-hand side. Does that make sense? So the argument C is going to be like the right-hand side of the plus, which is book two in this case. And the left-hand side is going to be like the object the operator is called on. Okay, and that's the general syntax for any of these. Plus equals, right? Um, the right-hand side is C, right? So in this case, it's book one. The left-hand side is like this object, which is book three. So in this case, contacts would be book three's contacts array. And then one more case in which you have something different is, oh yeah, also I didn't finish this part, but for this function, you could either make a new contact book and then like add the two contacts, like add these two together and then put that in the new contact book. The last case is going to be the equals equals operator. So equals equals is comparison, right? So it should return a Boolean value. Okay. So for operators, equals equals or like not equals is going to be bool. Okay, does that make sense? Did that answer your question? Yeah.
But when you don't set it, like, don't set it, like a certain thing, like, the board operator constitutes on the code. Like, if you don't set anything for that, then what does it add to, what's it add?
What do you mean if you don't set anything for that?
Like, you don't set to,
Yeah, so that wouldn't make sense, right? Because you need to be able to add something. Like it needs to take in. That's what I'm saying. So this thing in the parentheses acts as like the right-hand side of the expression. Okay? And the left-hand side is just like the object that you're operating inside the function, like the default object. Does that make sense? Okay. Yeah.
so the line, you're adding it to arrays.
Oh, so yeah, this is totally pseudocode. Obviously, when you add to arrays, right, you're going to be adding the elements from the second array to the first one using. Yeah. Guys, this is totally wrong. Okay, so don't use this. I'm just showing you like how you use it in practice. Okay.